Good morning. My name is Barry Dorrans. I am the security PM for all of .NET and NuGet and various other things that I just can't get rid of, even though I would dearly love to. Today, we're going to talk about security in ASP.NET Core 2.1. We're going to cover some things that we're in 2 because some of you might not know it, and I'm not going to make the assumption that everyone is already migrated to Core, although obviously you should be. So my job title in the Microsoft global address list is .NET Security Curmudgeon, because I am grumpy and horrible and chain smoke and swear at people, as my colleagues in the front row can attest to. I generally get to annoy everybody about coding securely. I tell them what to do and then cry when David Fowler doesn't do it. And then I have to cope and clean up Fowler's mess when things go horribly wrong. If you want to follow me on Twitter or tag me on Twitter, I am @blowdart. It is not a particularly work-focused account. It has lots of swear words and lots of pictures of my dog. So I'm going to go through a bunch of things. I'm going to go through hosting, authentication, authorization, little bits of identity with a preview of what we're planning to do in 2.2. Well, a little bit after 2.2. But we're going to start off with the thing that makes me worry the most, which is hosting. And hosting means Kestrel. Kestrel is the ASP.NET Core web server. It has scared me for the last 3 years that we decided we would like to write our own web server again and abandon IIS, which of course is not cross-platform. So I can see the business reasons for doing it, but writing a web server from scratch is a security nightmare. We've had it tested by a bunch of external security firms who always go, wait, you've just written a web server and you want us to bash on it? And they get really big grins and get very, very excited. So what we have done in 2.1 is we have turned on HTTPS by default. It is everywhere now. In all our templates, you will have HTTPS. We have a tool that will generate a developer cert for you and trust it on Windows. If you're on Linux, trusting it is your own problem because Linux doesn't really have a security story, which is a whole other presentation. But it's on by default. You can take a box that says don't use HTTPS. If you do this, you are a horrible person. HTTPS is everywhere now. Chrome gets really upset if your website is not on HTTPS. Edge will probably follow about 2 years behind because that's what Edge does. So that's why it's there. You are testing in sort of the same environment that you will be running in production. Keep HTTPS on. And within Kestrel, HTTPS can be config-based, so you can have different certificates based on your environment. It can be selected automatically based on subject name and expiry date. That means it will rotate. And we have support for SNI. So SNI is when you have multiple HTTPS web servers listening on the same IP address. And so the initial connection comes in, and Kestrel will get it, and you can look at where it's going to go via the host header and send the right HTTPS certificate back. And like I say, we have a tool. Because generating self-signed certs on Windows is a pain in the ass, even in PowerShell, so we decided to make it a little bit easier for you. So .NET Dev Certs is the tool, because everything is a .NET global tool these days. And it'll create, it will delete old ones, it will push through the trust on Windows. So certificate config works a little bit like this. You can tell it where to get it from, which on Windows is the Windows Store. On Linux, it's a random file sitting on your file system unprotected because Linux has no security story. And if you have it in config, we will wire it up. Even if you don't have it in config, we will look for ones based on localhost. So the config only really comes into play when you're moving towards your production environment. Like I say, we have SNI, so SNI is a little bit complicated. Here we have certificate selection. We are going to listen and port 5005, and we have a bunch of listen options. So we load all our certs up, and then in the HTTPS options, we set a server certificate selector, and it will get the name of the certificate that it's going to look for, which is the domain name, and you can do a selection based upon it, and return the right cert or return the default and then get loads of browser errors. Web servers need tuning. Everything needs tuning. IIS has tuning, Nginx has tuning, Apache has tuning, and Kestrel is no exception. There are rather a lot of tuning options. We've tried to make these things safe by default. Depending on your environment, you may need to adjust things, keep alive timeouts, for example. We've selected for reasonably fast internet, but because you're in Australia, that does not exist here. You may need to increase timeouts for people who are in Tasmania, for example. There are lots of reasons to ban people from Tasmania, but again, that's another talk. More sensibly, if you are sending things to Africa, where people are on really old cellular connections, you will need to adjust your timeouts. But by default, we've chosen things that are reasonably appropriate for normal non-Australian connections. They probably work with Australian connections too. I shouldn't pick on Australian internet too much, but I've had to suffer with it since Sunday. Because we've put HTTPS on by default, we also have a bunch of options. We will add HTTPS redirection, so if you hit the HTTP site, it will redirect you up to HTTPS. And you can configure that, as you can see, by setting services options. Some people like to think that they just want to redirect up to HTTPS for a login page and then redirect down again. That's a horrible idea, and we don't support it, so don't do it. And then we have HSTS. This slide came out of a really long conversation on Twitter with a bunch of people who work on Chrome. HSTS is a flag that when you hit a site over SSL for the first time, you can send this header and it will say, never ever load this site again over HTTP, even if the customer types in HTTP in the URL location. And it's great, except for when it's not. HSTS is dangerous because it persists. Once you've sent that header, you send it with a timeout value, which eventually clears out of the browser after that timeout has expired. But trying to clear it beforehand is really, really hard. I have HSTS turned on my website because I trusted Azure to renew my SSL certificate. Last year, that failed. I no longer had an SSL certificate. It did not rotate. It ended up expired. And HSTS pinned sites will not load if there are problems with the certificate. Thank you, Azure. Someone got a really rude email the next morning. So HSTS is great, and you should enable it, but you only enable it once you've trusted all your certificate infrastructure. Here are all the problems that you have. Did you really want to cover all your subdomains? Did you forget a test site that's running off your production domain? Don't do that. Get another domain for all your test sites. How fast can you roll your certificate if the certificate has been accidentally revoked? How fast can you get a new one? Do your certificates actually auto-renew? Does it work? Thanks, Azure. What happens if the CA has been pulled out of Chrome's trust, as has happened with a bunch of CAs recently, that, funnily enough, PayPal are still using? I think in a month, if PayPal does not rotate their certs, Chrome will no longer trust it. What happens if you've got a bad revoke? How fast can you move from one CA to another? Are you monitoring your certificate status? Do you send something to your site every 5 minutes that will send an HTTPS request, look at the certificate, make sure it's still valid, and alert you if it's not? These are the things you need to take into account when you're going to use HSTS. So when you run it out into production, start with a really short expiration. Start with 5 minutes. And once you've got 5 minutes and that's been running for a week to 2 weeks, okay, you think you're good, increase it to an hour. And then a couple of months later, increase it to a week. And eventually ramp it up to where you are at, my HSTS flag is going to be for a year. And once you've had it working for 6 months, then you can consider preloading it. Preloading is where HSTS status are baked into browser builds. So a request doesn't even need to be sent. Chrome will know that your site is in the HSTS list, and it will just send everything over HTTPS. And Edge does it as well. So in ASP.NET Core, we default to 30 days for your HSTS expiration, and it's kind of a bad compromise between the 5 minutes that's recommended by Chrome and Edge for preloading and the year that everyone expects you to end up in. So use it, but remember, it is a commitment that nothing will ever go wrong with your cert infrastructure. You may get called at midnight when your cert expires and Azure forgot to roll it. So we add it here using app.use HSTS, and then we set a bunch of options. Preload is where you can say that your site is in the preload list, includes subdomains, max age, and we exclude hosts and a bunch of other stuff. HSTS will not work on localhost. We hard-coded that because it's so hard to clear HSTS status in your browsers that if we put it on localhost and then you decided to spin up another test website and that didn't have HTTPS because you hit puppies and kittens, the browser would still try and load it over HSTS. So localhost is excluded from all of this. So if you start trying to trace things in Fiddler and wonder why you are not getting an HSTS header on your dev site running on localhost, this is why. We are protecting you from yourself. So, Kestrel. When we had initially launched it in version 1, we said, please run it behind a proxy, run it behind IIS, run it behind Nginx. And everyone went, no, we want the speed. And I'm like, but it's a new web server. From version 2 of .NET Core onwards, we will support you exposing Kestrel directly to the internet. But I will underscore again that this is new web server code. We believe it's secure. We've had a couple of interesting bugs over the last few months, and we've pushed out Kestrel updates. There was one last month. So if you are going to expose Kestrel directly, you need to pay very close attention to the GitHub announcements repo for ASP.NET on Patch Tuesday. Because we don't push .NET Core patches over Windows Update, because that wouldn't work on Linux. And we made a promise that we would never patch underneath you, because sometimes patches break people. So you all need to be subscribed to the announcements repo on GitHub for ASP.NET and for .NET if you're going to expose Kestrel directly to the internet, because you will need to patch in a timely manner. So we've got hosting out of the way, and then we have authentication, knowing who you are. In our templates, we have support for no authentication. We have supports for individual user accounts, which is ASP.NET Identity, plus a bunch of other stuff. We have work and school accounts, so that's Azure AD. And we have Windows authentication that only runs on Windows. We have had a bunch of requests from people saying we would like integrated in Windows authentication in our Linux containers. That has made me cry so much that I'm actually now thinking about it, because Windows authentication underneath the hood is in fact Kerberos authentication, and I believe we can support it on Linux if you want to take a dependency on Samba, which is an interesting idea from a security perspective, but we are starting to look at that now. So if you are running in an AD environment and you are running in Linux containers because you don't want to pay all your Windows licensing fees, and you still want that smooth login of no one ever having to type anything in, we might get there. It'll be 3.0 or 3.1. And we have social authentication built in, so we have Facebook, Twitter, Google, Microsoft account, and OAuth. And there is a ton of social authentication services that are in that GitHub repo, in the ASP.NET Contrib repo. There are some really weird ones of social networks I've never heard before, but pretty much everything is going to be in there that you will ever need. So individual user accounts, like I say, we have a local database, so you are committing to having a database somewhere that will never, ever leak to the internet because bad, evil hackers got at it. You may wish to accept that risk. You may not. If you don't want to accept that risk, there is Azure B2C. Some people like it. Some people don't. Then there are other things. You can have like Identity Server, which still requires a database on the back end. You have ASOS and OpenIDIC. And then if you are stuck in government, how many people here are working in government that would like to admit it? For those people stuck in government, we have support for WS-Fed. Finally, that came out just after 2.0. So you can stick with those really, really old, but actually really secure authentication providers that government demands because they haven't moved on since the 1990s. The template auth, we will have our local database. You can configure your EF models for accounts and groups and everything else. We're quite opinionated about it. We don't allow you to change our password saving algorithms because we don't trust you to make the right decisions. I'm sorry, but that's true. So we have a bunch of reasonable compromises between speed of hashing and security, and we review those with every minor release, and we can tweak them somewhat and move things on. For work and school accounts, we have Azure Active Directory, and that's using OIDC underneath. Oh, look, this slide is now out of date because it says no WS-Fed support. So we support ADFS as well. So if you're working in an old networking environment where you haven't moved to Azure AD and you still want to do federated login with your Active Directory, you can use WS-Fed or you can use ADFS with OIDC. And then, like I say, Windows Authentication, which needs IIS. You can't expose Kestrel directly for Windows Auth. You're going to have to join your servers to the domain, which is an interesting idea from a security point of view. And there is no impersonation. It used to be that when people used integrated auth to IIS, then IIS would run a process as that person. We don't do that because we think it's a terrible idea. You then have to specifically choose when you want to impersonate, which usually is when you want to talk to a database. And then it will automatically unimpersonate once it's done. So for those of you that haven't moved to Core and are still stuck on the classic ASP.NET framework, there are a few changes. Everything now is a claims principle. We have multiple pieces of authentication. Well, it's not middleware anymore, but it's close enough. You can have multiple ways to authenticate within the same app. So you could have Facebook and Twitter and Google and local databases and WS-Fed and OIDC all at once. You can cherry pick which one to use, depending on where you want to go. And you can run one automatically at a time. If you have multiple ones, you have to choose which one is your main one, which is generally Cookie. And then you can pick and choose what gets triggered when you go to certain endpoints or by calling sign in your code. And we have Cookie Authentication, which is the backbone of everything. That's generally how your identity is going to be persisted through the browser in a nice encrypted and signed cookie. And it finally understands the difference between authenticated and forbidden, which for the longest time it did not. So everybody got the same login prompt no matter what they tried to do. So in Core 2, we changed it. So authentication is now a single service. It's not exactly middleware anymore, like I said. It's services within the service. And we have this whole thing between active and passive that was a real mess in 1.0, and we fixed it in 2.0. So this is this whole, I want to choose my default authenticator, and everything else is optional. It was really easy to mess that up in one. You were only ever supposed to mark one piece of authentication middleware as active, and the rest would be passive, and then you do your picking and choosing. But there was no enforcement of that. So you ended up, if you had more than one piece of active middleware, in what we euphemistically called an unsupported state, which is a nice way of saying, we don't know what the hell's going to happen now. So we have enforced that now. If you are migrating from 1 to 2, these are the changes that you will need to make. It used to be app.use and then the middleware. And now we have services.add, and then in configure we have use authentication. And here is how we set our defaults. So if you are supporting, for example, social auth, we have default challenge scheme, default sign-in scheme, and default authenticate scheme. Now this is worth explaining. So if I do a social login, say I go to Facebook, and I come back and I get an identity from Facebook, I need to save it somewhere so every single request doesn't go through this Facebook hop, because that would be irritating as hell. So when I say that generally the default that you want for everything is cookie, that's what we end up doing. You do your Facebook auth, and then we write it to a cookie that is dropped on the machine. So in the V2 section down here, what we have is we have our default sign-in scheme, which is cookie. We have our default authenticate scheme, which is cookie, and our challenge scheme, which is off to OIDC or off to Facebook. So challenge happens when someone tries to access a protected resource and they are not logged in. So when you hit something that has the authenticate attribute on it, we will go off to Facebook. But sign in and authenticate are cookies, because that helps us rehydrate from the cookie on every single request. We don't want those to be Facebook or OIDC, because that won't work, because every single request you would get bounced out and come back in again, and it would be horrible. Does that make sense? Okay. And then if you are migrating from 1 to 2, you're really behind the times. You should have done that last year. We've changed how things work. So instead of everything being in ASP.NET Core HTTP authentication, we've just moved it up to authentication. And you use context.authenticate, challenge, and sign in to trigger all these things. If you forget to make it, you get a weird-ass error, or you get warnings saying you're using deprecated code. And if you want to do everything yourself, if you hit the templates that we give you for ASP.NET Identity, and that's fine, I honestly don't care. I would like to know why you hit them, but that's what GitHub issues are for. You can do everything yourself. You can use our cookie middleware or our cookie services and get the security that we built into those with your own identity. So you could go off and use a database of your own, and then instead of having to figure out how you want to secure and encrypt cookies to save that identity through requests, use our stuff. It is properly documented. We properly documented this in 1.0, and we've kept the documentation up to date, unlike previous versions of the framework where there was no documentation for this whatsoever. So the cookie stuff will encrypt and sign cookies. It uses data protection, so you can synchronize your keys across multiple instances of your website, and you don't have to worry about this. So here's how we can configure it. We just add cookie authentication with a cookie scheme name, and a scheme name is just basically a key in a dictionary. And then you call sign in with the cookie scheme name and the user principal that you want to persist, and you call sign out with a cookie scheme name, and everything else is taken care of for you. With each request, we will look for the cookie, and if it is there, we will rehydrate the identity for you and shove it on the user property for the request, for the page, for the controller, for the action. It will be there for you, and you don't have to worry about it. You can write your own authentication handlers. I've got a couple of sample ones. I've got one for certificate authentication. I've got one for basic authentication, which no one should ever use in production, but people were bugging me, so I wrote it, which would show you how to write your own authentication handlers. It's rare that you'll need to do this. If you do need to do it, I'd love to know what you're trying to do. Please drop me an email. So once you drop a cookie, it is the sole source of truth. Because the services will kick in and rehydrate every single time, we are not going back to a database every single time, because that would be horrible in terms of scalability. But the cookie service has the concept of a validator. And in the validator, you can go back to a backend database yourself. So say, for example, you have an HR system. You may well want to go back to a database and check that the user has not been fired in the last 5 minutes. You probably don't want to do this in every single request, because like I say, it's going to kill scalability. But we have validators that can reject the principal that has been rehydrated from the cookie, or it can even replace them. So if someone gets promoted, you could change their job title on the website. So you wire this up in the options on the cookie middleware. We do this for you in ASP.NET Identity. We refresh every 30 minutes, and you can actually look at how Identity does it to figure out if that's going to work for you. Here's how we implement a validator. It's not very exciting. Replace means I don't want to throw the user out. I'm just going to say that they have new roles or they have new properties. Reject does what you think it's going to do. And then here's how you wire it up in the cookie authentication events. And we have authentication forwarding, which is new in 2.1. So we finally got to something that's new in 2.1. So like I said, we have ways of wiring up multiple authentication services. So we have, let's say, cookie authentication, and then I have a bunch of APIs. And hopefully we're all aware, because Troy has told us, that authenticating against APIs with a cookie is just really weird, and you may not have cookies if you were calling them from phone apps or something else. And you want to use JOT tokens, because JOT tokens are the new hotness, and no one loves XML anymore, and no one wants to do WS star identity. Come to my PubConf talk, and I will tell you how wrong you are. And we supported this in version 1 and in version 2. You could choose the scheme that you wanted to use during authentication by putting it on a property on the authenticate attribute, or putting it in an authorization policy, which I'll come on to in a bit. And that was, in my mind, the right way to do it. You would apply it to a controller, because as you're well aware, there are multiple ways to route to a controller, and nobody should be doing anything based on request path. But because my customers are horrible people, all of you want to do it based on request path. So now you can do it based on request path if you want to make me sad. We have authentication forwarding. So each each authentication service has a forward default selector option. And in the forward default selector option, you can write your own code. So here I've got cookie authentication set up, and then you can see that if my path starts with /API, I'm going to forward it to the API authentication. This is a scheme name here. So like I said, we have scheme names. You can see up top I'm adding 2. I'm adding like a scheme, a fake API scheme handler. But then when a request comes in, the default will be cookie, and then cookie will go, wait, this goes to /API, so I'm going to hand it off to the API authentication handler. So now you can put this all in one place, as opposed to putting it in policies or in attributes within your code. And you can do things based on path, which may eventually help if you want to do multi-tenancy. Does that make sense? Have people been wanting this? No one's going to admit it because I'm going to tell you you're horrible? OK, fine. We also have virtual schemes, which is a different way of doing exactly the same thing, because we never like to give you one way to do things. We'd like to complicate things. You can set up a virtual scheme, which is an authentication scheme which has no authentication in it. It is just the forwarding inside here. So you would add authentication and say, I'm going to use my virtual scheme as my default. And then we add a policy scheme. We have our virtual scheme name. We have a display name, which you don't particularly need to worry about. And in our options, we can put a forward default selector in there and choose which one we want to end up with. 2 ways of doing exactly the same thing. I like this way, because then it's not on individual options inside handlers. And then there's API auth. So when we were back in classic ASP.NET, you could create an API project and say, I want to add individual authentication. And we had an authentication server built into previous versions of ASP.NET. And when we moved to core, I didn't want to bother with writing an authentication server anymore. There are an awful lot of authentication servers out there that are much better than anything we could produce. Identity server being the one that springs to mind, mainly because I have their sticker on my laptop. And so that option went away, and everybody said, I have an API and I want to add authentication to it. What do I do? And I'm like, use JotBearer. And the answer was, OK, how do I get a job bearer token? I'm like, you're on your own with that one. Which is not a good story according to management. They would like us to, not tell customers they're on their own. So we've been kind of mulling over what we wanted to do. And adding identity server or ASOS or OpenIDICT has been historically complicated. These things generally tend to require you to know more about OIDC than you ever wanted to know. So we decided for 2.1, in all honesty, this will probably come a couple of months after 2.1. It will ship out of band, and then it will be properly integrated in 3. We decided we wanted to fill that gap. And so we're like, OK, we're going to add authentication for API projects. And here we have a sneak peek of what we're going to do. And when we suggested we were going to do this, the community was somewhat vocal, I think is the polite way to put it. You see, we thought we could write a simple one that would do a lot of the work for us, and it was very simple to configure, and it was very limited in what it would do just for API, first-party API scenarios. And the community basically said, wait, you're killing all these third-party authentication services. You should use those. And we're like, OK, but you keep telling us they're really, really complicated to set up and configure. And they're like, no, we don't care. Use those. Stop killing off other open source projects, which was never the idea in the first place. We were going to give you a nice migration path. So we went, and all the code that we'd written, per Javier, all his code got thrown away. And it's like, OK, make integration happen. So we had to pick who to integrate with. And because I already have their sticker, we chose Identity Server. That is not the reason we chose Identity Server. Please don't quote me on that. So here we have a sneak peek of a work in progress. The names for some of these functions will change because, as sure as you're well aware, we suck at naming things. So here we have an API project. And here we're just going to use SQL Server. We're going to add ASP.NET Identity to be our backing database for this. And we're going to add Entity Framework. And then what will make a bunch of you happy is we add Identity Server. And then below that, we're going to go add ASP.NET Core Conventions. That will change because it sucks as a function name. And we will wire everything up for you. And we get really opinionated about this. You don't need to worry about generating your keys anymore. You don't need to worry about scopes. You don't need to worry about naming, because we are going to have a simple convention-based way of registering your applications in Identity Server for you at runtime. So you don't have to worry about any of the admittedly very flexible configuration for Identity Server, but also the quite overwhelming configuration for Identity Server. And then we're going to call services.addAuthentication like we always do. And then we're going to say, hey, look, I've got a local API in this project. So I'm going to call add local API. So here we have an API controller. Ooh, it's the stunningly excited values controller. And of course, down here, we also have use Identity Server. So if I run this, it worked last night. I may have pulled down the repo again this morning. So we'll see how this goes. Like I say, it's a work in progress. You are the first people to know that this is going to be using Identity Server. So if you're going to tweet anything, that's the thing to tweet. It will probably be delayed by a couple of months after 2.1 as we try and get different scenarios working. I want to get to the point where you do a new web API project and you choose individual auth with Identity Server, and then when you add a new API project to your solution, that will also get wired up. And I also want to get to the point where API projects can authenticate themselves to other API projects as one project to another. And once we've got that and I'm happy, that's when we'll release. And also, it has to be simple because I care about the experience. I don't want people to have to write configuration for themselves. Now, when you sort of like move outside our scenarios, then you just, you drop back to using an identity server without our helper classes. And we will give you a bunch of migration documents that tell you, these are the conventions that we did. Here's how you do them manually in identity server. Now you're adding more stuff. Here's how you switch to going from identity server with training wheels to identity server with its big turbocharged engine. So here we have a template prototype SPA client. This will not be in the final template. This is just to prove that everything works. When the final templates come around, it will probably just be a REPL so you can type code. Kind of need to figure out how I can do OIDC within a REPL, but we'll think about that when it comes to it. So if I click login, this is identity server. It's identity server embedded in your project. There's no identity server controllers or anything. The whole UI is embedded just like we have done with ASP.NET Identity. So if I log in here, and I've remembered my password, and it hasn't broken. Oh dear, what changed from yesterday? Oh, there we go. No, you're logged in. There we go. So I am logged in now. I have gotten a JOT token back. It's not cookies anymore. And because I have a JOT token and it's saved in the browser as a JOT token using JOT local storage, I can call an API using the same methods that I would use to call it from a mobile app. So we have the same authentication mechanisms between our web app and our mobile app, and I no longer have to support two different types of authentication. So I can call the API, and it's good old values controller, and that's not sending a cookie anymore. It is sending a JOT token using identity server's client for these things. Their JavaScript client for doing requests. So we have integration with the community's probably most popular third-party authentication service. And you can still keep everything local. I mean, you could obviously do this with Auth0 as well if you want to have all their stuff stored in the cloud. But identity server seems to be where it's at, and it is incredibly flexible and can do all sorts of wonderful, magical things. So that will come maybe a couple of months after 2.1, and there will be templates, and there will be magic, and it will all be gloriously documented, and you won't have to worry about configuration because we will know that there is an API project and an identity server, and we will just wire it all up by magic. Do we like this? Yeah? Is this what you wanted? Yes. Okay, thank you for saying that, because this has been like a year of work, and if it's like, no, I don't want that, I'm just going to go home and cry. So identity server is what we chose. You get your integration, and if you're going to tweet anything, that's the thing I would love you to tweet, because it will make Dominic and Brock very happy. And instead of me buying them dinner, it might be the other way around for a change. So, well, that's glorious. Data protection. So I said that we encrypt and we sign things in authentication cookies, and this is how we do it. This is pretty much the same as last year. Nothing has particularly changed. So if you sat in this last year, I'm sorry, this is pretty much the same. You got your exciting stuff with Identity Server. I feel happy about that. But we need somewhere to store our encryption and signing keys. And it used to be in web.config, we had the concept of machine key, which was a hard-coded signing key in a config file. How many of you have ever had to change your machine key? Okay, of those people that have had to change it, how many of you were in web farm scenarios where you had to change it on every single machine at once? It sucked. This was not my idea. Web.config was long before I joined. Okay, so you can't blame me for that. I know who you can blame. If you give me cash, I might give you their email address. So we got rid of web.config, as you're well aware, because nobody likes XML anymore, and now everything's in JSON. But we got rid of machine key, and we replaced it with a data protection layer. And so what we have now is automatic key generation, automatic key rotation. We choose algorithms for you. We isolate applications automatically. We isolate based on purpose. We figure out where the key should be stored based on app platform, which mostly works until you publish to Azure and want to use slot storage and slot swapping, in which case it breaks horribly because Azure still haven't given me that function after 3 years of asking. You can easily write new key stores, so you can match things to your customers' environments. If they're not in Azure and they have a SQL database and they want to store all their encryption keys in SQL, you can write your own. We can support custom algorithms, which is not for you, it is for Russia. Because Russia doesn't allow you to use American encryption algorithms anymore, because they all have flags in them and they wave their flags. So Russian encryption algorithm, which is GOST, you can write your own encryption algorithm and plug it in. We do not provide a GOST implementation for you, because trying to write one of those outside Russia is interesting, and the Russian government can get quite upset. But the custom algorithms are there. It's the same with China. China now wants people to use their own encryption algorithms as well. So if you are trying to sell a service to China, you may well need to wire up the Chinese algorithms. And there are NuGet packages for GOST and the Chinese one whose name I can never remember. And then you can just wrap these things around, but they are not provided by Microsoft. So here is what how we configure things, which is what your security people want to know. We do not hide this away. It is in the source code. And if they go around and say, well, what's the encryption and signing on this? You point them to this slide, and that's what we choose. So it's split up into two concepts. We have a key store, where we store your keys, and then we have protection for that store. So by default, you write your keys to a store. They're not protected. They're in plain text. You have to layer on protection on top of it. So you want the two of these things together. And so we have key stores for Azure Web Apps. It's in a special synced folder, and by default, that's unencrypted. With IIS with no user profile, well, it sits in the registry, and we actually use some Windows capabilities to protect it. An IIS with a user profile, again, we store it in your app data folder, and we use Windows capabilities to protect it. And we also have an in-memory one, which is where we used to default to. So we aim data protection at ephemeral data, data that you don't care about losing. So having it in memory is just fine until you have, like try and scale out, and then you're like, it was in memory, what do I do? And you have to switch to various key stores. And then we have protection mechanisms. So we have a couple of Windows-specific ones, DP-API and DP-API-NG. Then we have good old X509 certificate. We have Azure Key Vault support. And then we have plain text. If you really don't care, then don't protect it. But if you persist your key ring properly, if you stick it in a SQL database, if you stick it in Azure Blob Storage, if you stick it in a persistent Redis provider, you can use this for non-ephemeral data, but you're on your own. We've tried to make it as foolproof as possible because we realized people would use machine key protection on their own data and then complain to us when they updated their machine key in web.config that their data didn't decrypt anymore. And we're like, yeah, because you changed the key. Did you keep a copy of the old one? No? Oh, okay. So we don't ever delete keys anymore. The key ring just grows bigger and bigger and bigger, but it's tiny anyway. Stick it in blob storage, you're good. It'll cost you like maybe 1 to 2 cents every month. You can use it manually, like I say. You just create a data protector from it with a purpose, and you just call protect and unprotect, and it will use the key rings. So here's how to do it like in memory. The ephemeral data protection provider is our in-memory one, which we use in tests. You read things, you call protect, and then you call unprotect, and lo and behold, we're done. Purpose strings are interesting. They provide isolation. So you really don't want to use the same key for different types of data. So say I am encrypting your credit card number is a bad example because you should never be saving credit card numbers, but we'll go with it anyway. I want to encrypt your credit card number, and I want to encrypt your email. You should be using different keys for each one So purpose would allow you to say, this is going to be an encryptor for credit cards with a purpose of credit cards, and this is going to be an encryptor for email addresses with a purpose of email. And they have separate keys that are all generated through all sorts of weird key derivation stuff. And they can't unprotect each other. There are a couple of caveats here. Don't use user input as the sole source of a purpose, because then a hacker can say, OK, well, I'm going to actually try and create a credit card decryptor when you really wanted an email one, and that's not a good idea. And you probably want to try and version your purposes, so as you change things or as you change formats, you can change your protector format. So there are configuration points, like I say. We have our key stores, where we're going to save the keys. We have how we're going to encrypt stuff in those key stores, and we have key expiration policy, which is how long we are going to rotate things, how long keys live for before they are rotated automatically. If you want to share key stores between applications, well, apps are isolated by default, so there's an application name that you can set, and if you set it to be the same, then they can share encrypted data between the two. And if you want to use it in older ASP.NET applications, we have a forward compatibility pack. We're not doing back compat for this. We're going to drag you kicking and screaming up. So we'll skip past configuration. And here's how to implement a key store. It's incredibly easy. You've got get all elements and store elements. And in 2.2, we will finally give you the Redis key store that has been ready since 2.0, and I just forgot to tell someone to flick the bit to production. Authorization. How many of you were here for this last year? So some of you are new, so I should go through this. Again, it's going to be exactly the same demo as last year that is rude to ginger people, so you have that to look forward to. So I'm going to run through this. I have an entire workshop for this, which is probably the best way to do it. It's maybe 2 hours worth of going through, and it talks you through building things up step by step. So we don't want you to write your own authorization attribute anymore, because that was hard, and it was wrong, and hard-coded things. Instead, we switched everything to policies. And policies are ways that you can express rules in code based on requirements. And we also have given you resource-based authorization. Everything is done in DI. We have our custom scheme filtering, which is what you should have been using to select stuff, but now we've got scheme forwarders, so use those if you want to make me unhappy. So we have things based on requirements. Requirement is just a marker interface. You can put properties into your requirements if you want. So if you have a minimum age requirement and you want to spin up lots of them, you could have a minimum age in here that you could then set to be 18 or 21 based on what you want to do. And then requirements have handlers. And handler basically says, OK, what needs to be fulfilled for this requirement to pass? And I put my code inside our handler. So here we're going to check that someone has a claim of a badge number and it's been issued back in Tozo. And obviously, you do more here. You check whether the badge is valid and so on. And if it is, if it's correct, then I'm going to say, yep, I'm going to do task dot, well, in this case, it's task dot from result 0, because I'm carrying about back compat to 1. But you can do task dot succeed and task dot finish. But the important thing to note here is context dot succeed. If your requirement has been fulfilled, you call context.succeed and pass the requirement back. And then we build our policies up by adding authorization and setting our policies. So here I'm creating a policy called building entry. I'm going to add our new requirement, which is office entry requirement. And then I'm going to shove our requirement handler into DI, because everything is DI based. And then when I want to authorize, I'm going to say authorize policy building entry, which is the one that we configured before with our building entry requirement. And it will go into our handler and call the code that we've written. In Razor Pages, everything's slightly different. You can set pages to be authorized, and then you can set the actual policy on the page model. So here we have our authorization demo. I'm rapidly running out of time because I got so excited about the API auth thing. It is lunch after this, right? Yeah. They always put me on before lunch because I run over. So prepare to starve, people. The workshop is a good place to start with this. So, as you can see, this is a custom demo for Australia. We're going to have the ability to change the weather and choose whether we go inside or outside. And what the rules will do is the policies that we've set up will be based on looking at the weather and where we're going to end up and who we are and see whether it's safe or not. So in the minute, it's winter. So I want to go outside. I'm going to choose who I am. Harry Potter. Ron Weasley. Some weird famous Australian chap. I don't know. So we'll go to Harry Potter. He can go outside in winter. That's absolutely fine. Because we're checking who he is and the weather and you know what the season is. However, if I choose the late great Steve Irwin, it's winter. And do you people realize how warm it is outside right now? And yet you're wandering around with layers on. It is hilarious. But apparently, you know, if it's less than 20 degrees, no one wants to go outside without 6 layers on. So in winter, it is too cold for Steve Irwin to go outside. So let's sign out of Steve, and we'll change it to Aussie summer, forcing climate change. So now it's summer. So I'm going to go outside again. I'm going to be Daniel Radcliffe. No. You see, now it's summer, and British people should not go outside in Australian summers because they'll burn. Okay? But if I go outside as Steve Irwin, it's fine because now it's summer and it's finally warm enough for Australians to go outside. Okay? Just watch out for your drop bears. And then, you know what? We have Rupert Grint, and honestly, because he's ginger, it doesn't matter what season it is, ginger people should not go outside in Australia because it's too sunny and you'll burn to a crisp. So we should look at the code behind this. I love doing this one because in America, they think ginger people are real people. It's really quite bizarre. They don't understand this. One of my friends married a ginger last week. I went to the ceremony and then like literally fled the ceremony to get a plane to come here and got there like 10 minutes beforehand. And before I went, I gave them both a big hug, and then I got a text from my friend saying that his partner was deeply amused that they got a hug. And I went, no, it's fine. You have half a soul between you now. It's okay. I'll hug them. So what we have is we have requirements. So we have a location requirement that's going to be inside or outside. And then we have an authorization for gingers, which is specific to poor Ron Weasley. And we have a weather provider, which is where you probably go running off to your database. So what we do is we are going to add a policy for inside, and we have a policy for outside, and we're going to add the handlers for those, because it's going to be the same handler for multiple policies or for multiple requirements. They're all going to handle location requirement. And location requirement for gingers basically says you can't go outside or inside at all. You're in Australia, it's bad for you. Whereas our normal requirement handler will make it depend based on your nationality. It doesn't take hair color into account. Go through the lab, it becomes a little bit more clear, but I'll try and explain it now. So policies are made up of one or more requirements, and all the requirements have to succeed for a policy to pass. And all requirements are evaluated just in case you want to log. And handlers are handlers for requirements, and you can have multiple handlers. So there are multiple ways to fulfill a requirement. The way to think of this is getting access to your office. If you have to swipe a badge to get access to your office, that is one way of fulfilling your office entry requirement. But visitors need to come in too. So they get like little visitor badges, which don't swipe, but the receptionist will press a button. But their visitor badge is another way of fulfilling the office entry requirement. So you have two handlers for a single requirement. And if either one is fulfilled, then the requirement is fulfilled. And when it's successful, you call context.succeed. When it's unsuccessful, you do nothing at all. Because, like I said, there are multiple handlers on a requirement, so the next one might succeed. There is a context.fail. That is not something you generally want to use. It is for horrific circumstances. It's for the, I need to short circuit everything. It's like, I don't care if another handler will succeed. So my database is on fire. Don't do anything more. But normally, it's not something you will want to call. And you can do this imperatively as well. Because everything is based in DI, you can take authorization service into your controller and call authorize async with a policy name. If you're inside a view and you want to do things, if it fails, just return new challenge result, and we will take care of all the prompting for logins or the forbidden or unauthorized stuff for you. Just always remember to register your handles in DI. If you don't do that, nothing's going to work. And you'll sit there going, why is nothing working? And then you'll remember that you have to rewrite or register your handles in DI. And if you are using databases, of course, just remember to change the scope during your DI injection of the handlers. We have resource-based authorization. So say you have a document and someone wants to edit it. You can change your resource, you can change your authorization based on what that document is. So it's like, hey, you're the author of this document. I'm going to let you edit it. Or you're the admin of this SharePoint site, I'm going to let you edit it. So it's based on operation. Again, this is in the workshop. But you can do all sorts of funny things. So here is one that takes an authorization handler, this time for a resource. It takes a requirement, but this time it's also taking the resource itself, a document. And that will then pass through to handle requirement async. We've got our document. I'm going to look at a property of the document and then decide whether I want to succeed or not. Here's how we add authorization everywhere. This will work for Razor Pages too. And if you don't like scheme forwarding and want to do things the correct way, although Fowler will disagree with me, then you can actually limit by schemes inside your policy. And you can do things if you're an MVC because the authorization service is in DI and you don't want to use view models because you're a horrible person. You can inject the authorization service into your view and call authorize async in your view and then show or hide things based on the result. Do it in view models, for heaven's sake. Just remember to then duplicate those checks on the back end because otherwise people will just hit your routes directly. If you don't like it, you can throw it away. This is what Policy Server does. They replace our entire policy provider with their one that then allows you to set rules based in a database in a server somewhere else. So we're getting towards the end. ASP.NET Identity is our database for storing usernames and passwords. It used to come with an awful lot of crud in the templates. Because we have this lovely facility now in MVC 2.1 to bundle everything, including UI, into a NuGet package, we've done that now. So, you know, if you create a new solution with identity, you won't see any of the identity controllers, which is great until you want to come to customize things. And you're like, how do I customize it? Well, you right-click and choose Scaffold Out, add new scaffolded item, and you will see identity in there. And it will extract everything out, and lo and behold, you have all your controllers and UI back again. You can also use this to add identity afterwards. So if you've got a project and you're like, oh, darn it, I need a login. I need a login screen. I need usernames and passwords. You can also just do add new scaffolded item and choose ASP.NET Identity. We have GDPR points because everyone likes those cookie prompts. We are not saying ASP.NET is GDPR compliant. We are saying that we can help you meet some of your obligations. There was an awful lot more to GDPR than this. My manager keeps joking that he will stand up one day and say, if you use our templates, you're fully protected for GDPR, and he knows that's wrong. But we'll give you extension points in our templates for data downloads and deletion. We give you extension points for encrypting data at rest, although for heaven's sake, don't use them. This is the last possible resort for this stuff. This is when you are using a database that does not give you encryption at rest, but you realize you still need it. Use a database that gives you encryption at rest. It's so much easier and it's transparent to you. And we have two-factor authentication for your nice little TOTP apps. And for GDPR, outside of identity, we have support for those annoying consent dialogues. Once you start implementing this, it gets a little bit more interesting. If a user has not consented, ASP.NET will not drop cookies that are not marked as essential. So you have to change, you have to rethink how all your cookies work and choose whether you want to mark something as essential or not, and be prepared to argue that they are in fact essential when Europe comes down on you with a great big heavy boot. Here's how we sort of wire it up. Cookie policy options, we're going to check whether consent is needed, and that will go away and look for something, and that something is up to you. And then when we are creating cookies, we can set a cookie option that says something is essential. And in our views, we can use this to set the consent to being tracked or using non-essential cookies just by dropping another cookie, funnily enough, because that's the only way to do it. So that's a quick run of where we went. That has covered things in 1.2.2.1 and what will eventually come about 2 months after we have dropped 2.2. I am aware that I have run over by 2 minutes, so if anyone has questions and hates everyone else in the room enough to keep them from your lunch, now is the time to put your hands up or come sneak up. There is someone that hates you. There's a man at the back. Man at the back. What would you like to ask to keep everyone from their lunch? Yes. So the question is about unit testing the authorization policies, and you say it's very hard. I would honestly argue that it is not. But that's just me, because it's you test the handler. So you just call authorize async, you pass it in a mocked up request and check what comes out again. Now, I think we need to talk a little bit further about why it's hard for your circumstances, because there's probably something I'm missing here, like whether you have database dependencies or something else that's slightly weird. But in theory, it is just a matter of mocking up or creating an instance of the requirement handler that has everything that you want mocked around it, and then call it and see what drops out the other end, which to me is easy, but I must be missing something. So if you want to like delay your food gratification and come up and have a chat, I think that's probably the best option. Does anyone else have questions? Yes. Yes. So the question is, if we are going for the new fancy web API stuff and you issue a JOT token, what do we use for private keys for signing that JOT token? We take care of that for you. We will, oh, and how does it get distributed? Okay, that becomes slightly more interesting. We're going to give you a key provider in much the same way that you can do with Identity Server right now. We will give you one that looks roughly like the data protection providers. So you can say, I want to share my key via Redis, or I want to share my key via SQL, or I want to share it by blob storage. That is in my list of things to do, which is why it's going to come 2 to 3 months after 2.2 launches, but we will be supporting your scale-out scenarios for this. It's just not quite there yet. It's all hidden away in a private repo that you can't look at yet either. Give it about a week and a half, and it will all be public, and then you can all start creating issues like, well, what about this, what about that, what about the other, and make Javier really, really sad. Does anybody have any more questions, or would you all rather go for lunch? I'm terribly sorry I ran over. You can grab me over the next couple of days and just pester me about more questions. Enjoy your lunch. Thank you very much.